All right. So we're in section 3.3, graphing with intersects. All right. This is going to be a little bit different than graphing the other way, but we're going to try to keep the two things separated. And I'll show you how to separate them in a minute. So let's talk about, first of all, where are two different ways to draw a graph. All right, there are two different ways to write a line. The two ways to write a line, there's one way to do it. Let's talk about the main way first. The main way to write a line is to write the line in slope-intercept form. I'm referring to the second bullet point here. The main way to write a line is in slope-intercept form. That is y equals mx plus b. Now, we've seen that before, we just don't know it. Y equals 3x minus 1 is slope-intercept form. Y equals 1/2 x plus 1 is slope-intercept form. Notice that you basically have a y equals, you have a number, you have an x, and then you have another number. Y equals 1/2 x plus 1, or 1/2 or 3x minus 1. So you've seen it before. It's the form that we've seen before. M is slope, because M stands for mountain. Mountains have slopes. M equals slope. And 0b is your y-intercept. That is the main way that we write a line. There is, however, a second way to write a line, and that is this. We can write it in standard form. Standard form has the form ax plus by equals c. Now, what does that mean? That means you have x and y on the same side, not on different sides. So, for example, 2x minus 7y equals 10, or 3x plus 7y equals 8. Notice that x and y are on the same side of the equation, not on different sides. So to put it simply, standard form has the x and the y on the same side, and slope-intercept form has x and y on different sides. That's the main difference between the two. So now let's talk about how we're going to draw a line, graph a line, when it's not in slope-intercept form. The line is in standard form. So, intercepts. We are going to graph lines in the form ax plus by equals c. For example, we're going to graph a line 2x plus 3y equals 6. That's going to be our goal for this first part of the thing. Now, because it has a different form, it's in standard form, we're not going to make a table. What we're going to do is use the intercepts of a line. Now, what are intercepts? To figure out intercept, let's think about interceptions. Let's imagine that we have a Q. Q's our quarterback. He plays for some NFL team. He throws the ball to S. We'll call S Steve. Steve is his receiver. Steve is supposed to get the ball when the quarterback throws it to him. But P, over here, another player, we'll call him Pat. Pat is trying to intercept the ball from Steve. Pat does not want Steve to get the ball. So what is Pat going to do? Well, the quarterback takes the ball, he throws it to Steve, and what does Pat do? Pat runs from this direction. And at this exact moment right here, what does Pat do? Pat keeps the ball away from Steve. He catches the ball and he runs in that direction. So what did Pat just do? There's a path. The path the ball is on is right here. The ball is going in this direction. This is the path. Pat crosses the path right here. intercepts the ball and runs in a different direction. He crosses the path that the ball is on so that he can intercept the ball. Intercept simply means to go through or cross. That is what intercept means. So now let's apply that to math. What is the x-intercept? It's where our line would cross the x-axis. This is the x-axis. This is our line. Where does it cross the x-axis? The x-intercept. What is the y-intercept? It's where our line would cross the y-axis. This is the y-axis, right? This is our line. Our line crosses the y-axis at the y-intercept. Now, that's what the x-intercept is. What are we going to do about that? Why does that help us? Here's how it helps us. First, let's take that idea and let's identify some intercepts. Let's just say, where are the intercepts at? Where are the x-intercepts? Well, the x-intercepts are here, here, and here. This is the x-axis. This is our line. It crosses the x-axis at -1, +1, and 2. So our x-intercepts are -1, 0, 1, 0, and 2, 0. Now there's a reason why we put those zeros in there. We'll get to that in a minute. But for the moment, let's just say that the x-intercepts are -1, +1, and 2. Without making them ordered pairs, which we will do in a second, let's just say it's right here, right here, and right here. We know that already. That's where it crosses the x-axis. That's what an x-intercept is. What's the y-intercept? Well, the y-intercept is right here. It's at 4. So our y-intercept is basically 4. That's where it crosses the y-axis. This is the y-axis. This is our line. It crosses it at 4. So does that make sense so far? Right here is the y-axis. This is nothing. That's just a random point up there that just kind of happens to be on the graph. It doesn't really cross the x-axis or y-axis. It's just up there doing nothing. So we don't really care about this point. We just kind of cross it out and say, nah. All right. Now, notice the answers are not just -1, 1, and 2. They are ordered pairs. Notice this is an ordered pair, that's ordered pair, and that's an ordered pair. This is also an ordered pair. So let's remember that the answers are ordered pairs and not just single numbers. So let's keep going. Remember, every point on the x-axis has y equals 0, and every point on the y-axis has x equals 0. So now we're about to find them out using that information. We know that every point on the x-axis has a y of 0. We know that every point on the y-axis has an x of 0. We know that. If it's on the x-axis, y is 0. If it's on the y-axis, x is 0. We know that. Therefore, if I want to figure out where a line lands on the x-axis, all I have to do is see what happens when y equals 0. Because isn't it true that every point on the x-axis has a y of 0? Wouldn't those two things correlate with each other? That if y is 0, that we're on the x-axis? Yes, it would. And wouldn't they equally correlate? Is if I figured out what happens when x equals 0, I would know what's happening on the y-axis. Because isn't it true that on the y-axis, all the x's are 0? Let's do that. So this is going to be our methodology. To find the x-intercept, to figure out where it lands on the x-axis, I'm going to set y equals 0 and solve for x. And vice versa. I'm going to find the y-intercept. I'm going to set x equals 0 and solve for y. So now let's do that. So now let's take our first example, 2x plus 3y equals 6. I'm going to take this example right here. To find the intercepts for the line 2x plus y, 3y equals 6, we will first find the x-intercept. We will do what we say we were going to do. We will set y equal to 0 and solve for x. So we'll take our original equation, 2x plus 3y equals 6. We will set y equal to 0. We will say, y, you are now 0. And we will now go to our next step. 2x plus 3, what is y equal to? It's equal to 0. You know why? Because we said y, you're equal to 0. And equal 6. So we set y equal to 0. We just say y is equal to 0. We just say it. And we plug it in. 3 times 0 is 0. If I have $5 and then I get $0, how many dollars do I have? The same amount. So if I take 2x plus 0, that's just 2x. I didn't add anything. So 2x plus 0 equals 6 becomes 2x equals 6. We only take one step for that. We divide by 2, and we get x equals 3. So the x-intercept is 3, but remember, this is on the x-axis. What's true about every single point that's on the x-axis? Y is equal to 0. So the x-intercept is 3, 0. Because x is 3 and y is 0. Okay. Now we're going to find the y-intercept. We set x equal to 0 and we solve for y. Why do we do that? Because if it's on the y-axis, which is what the x-intercept is, it's where it crosses the y-axis. If it's on the y-axis, we know that x is equal to 0 on the y-axis, and we solve for y. So we go back to our original equation. 2x plus 3y equals 6. Now is y still 0? No, it's not still 0. Y is, we just say, we don't know why it's. Is x 3? No, because we declare x to be 0. We say x, you are now 0. We say 2x plus 3y equals 6. So we put 2 times 0 plus 3y equals 6. We get 0 plus 3y equals 6. 3y equals 6. We divide by 3, y equals 2. So the y-intercept is what? Is it just 2? Nope, it's an ordered pair. What's the ordered pair? Well, an ordered pair has an x and a y. What's the x value? 0. What's the y value? 2. We just found that out. Okay. So that's how we find the x-intercept and the y-intercept. Now let's graph this sucker. All right, everything I just said is summarized on is on this thing here. You can go through, you can read it. If it makes sense, let me know. If not, then I can try to simplify this some. I tried to say everything that I just said on this slide. Basically, you cannot simply just, when you go to the computer, it will not let you put x equals 3. If you put x equals 3 as the x-intercept, it will say no. You will get really confused. But you have to remember that if you have an x-intercept, it has to be 3, 0. If you have a y-intercept, it's got to be 0, 2. If you just put 2, the computer will yell at you. It will say, no, you're wrong. And if it tells you that, you have to be aware that the problem is it has to be an ordered pair. If it's not an ordered pair, it will not accept it. It will say, we don't like that. The computer will not like you. It will reject it. And the reason why is when you do an x-intercept or a y-intercept, which you'll see problems like this, it has to be an ordered pair. If it's not an ordered pair, it will not like it. It will reject your answer. Now, for graphing purposes, it's not nearly as important. It kind of is important, but not as important as when you're trying to put it in the computer. So I realize that I'm pushing a whole lot on that. I'm putting a lot of stress on that. The reason why is because I don't want you to get to there and be really confused and go, but I put the right answer. Almost. You've got to put an ordered pair. All right. I realize that I'm just kind of hitting that really hard, but it's super important. All right. Let's continue. Okay. To graph it, all you do is you plot your 2 points. We said the x-intercept is 3, 0. We go 1, 2, 3, 0. That's 3, 0. The y-intercept is 0, 2. 1, 2, 0, 2. Or we can say, well, x equals 3, right? Yeah. So we go to the x axis and we go 1, 2, 3. We put a dot. And we said y was 2, right? Yes. So we go 1, 2 on the y-axis. We put a dot. And then we draw a line through it. That's how you do it. Okay. Let's do a second example. All right, second example. Negative 3x plus 2y equals 12. To find the x-intercept, we said y equals 0. We solve for x. So I'm going to kind of pass through all the steps real quick. We get x equals negative 4. The x-intercept is negative 4, comma 0. Why? Because you can't just have negative 4. It's got to be negative 4, comma 0. If you say negative 4, comma anything else, it's not right. Negative 4, comma 0, that's the x-intercept. We fill the x, make the other one 0. We find the y-intercept. Find the y-intercept, we set x equals 0, and we solve for y. So we do that, we get negative 3x plus 2y equals 12. We set x equals 0. That basically goes away because it's 0. We solve for y, we get 0, 6. Then we graph those two suckers. And as you can see, you have the x-intercept of negative 4, 0, and 0, 6. So negative 4 on the x, positive 6 on the y. Draw a line through it. All right. That is how we graph using intercepts. It can be really tricky to understand. You need to practice it like crazy. Work out your problems. It can be a lot to kind of comprehend initially, but it's a pretty straightforward concept once you do it a bunch of times, like most concepts in math. All right, that is pretty much the end of that recording. You should be able to then kind of start working on the 3.3 homework. All right, I am done. See you guys later.